This is jet propulsion. Jet propulsion means propulsion of movement of bodies such as ship, aircraft or ship, aircraft, aircraft or rocket, etc. Rocket, etc. with the help of jet, all with the help of this jet. The reaction of jet coming out from orifice provided in the bodies is used to move the bodies. This reaction is used to move the bodies. A jet of fluid coming out from orifice or nozzle when strike a plate exert force on the plate. This jet when strike a plate exert a force on the plate. Exert force on the plate. Plate. If a jet is coming out and striking to the plate, what we have discussed in our earlier classes, exert a force on the plate, the similar force will also exert in this nozzle. Now, this force is exerted on the plate. That plate may be flat, inclined, or curved, stationary, or moving. The force exerted by jet on the plate is called as this force exerted on the plate. That plate may be flat or inclined. Plate may be flat or inclined or curved. That plates may be fixed or moving or moving. In all the time, this jet apply a force on the plate. This force exerted by jet on the plate is called as action of jet. This is called as action of jet. And from the Newton's equation, Newton's third equation, third law, we know that every action there is an opposite reaction. Reaction is always there. So this force exerted by jet on the plate is called action of jet, and the opposite coming out from the orifice or nozzle, this is coming out from this orifice or nozzle, exert a force on orifice or nozzle in opposite direction. In orifice or nozzle, this force is acting acting in opposite direction. Force is acting in opposite direction. Opposite direction. This force is called reaction of jet. This is called reaction of jet. This is the reaction of jet. If the body in which orifice or nozzle is fitted is free to move. Now, if this orifice fitted in the body is free to move, then the body starts moving in direction opposite to the jet. If here direction of jet is this, then the body will move in the opposite direction like this, where the orifice is fitted. Orifice is fitted. Okay, so if the direction of jet is this, then the body where orifice is fitted will move in the opposite direction, in this direction. Here, this is the next topic, jet propulsion of tank with an orifice. Here, this is the tank is fitted with frictionless wheels in the bottom, and here one orifice. From here the water is coming out. This is full of water, and the height of this center of the orifice to the top is capital H, and this is the force acting on the body in opposite direction to this velocity of jet. This is the V is the velocity of jet, and F is the force acting on the body. Because of this, due to the frictionless wheels are fitted here, this body start moving in this direction, opposite direction. This is the reaction. Now if H is the head here, H is the constant head of water in the tank from the center of orifice. This is constant head, constant head from the orifice. A is area of orifice, A is area of orifice, orifice. V is velocity of jet of water, V is velocity of jet of water, V is velocity of jet of water. Cv is coefficient of velocity of orifice, coefficient coefficient of velocity of orifice, orifice. So here V is equal to Cv root 2 G H. This formula is used, and the mass of water coming out from orifice per second. This mass of water coming out from this orifice is rho into volume per second, volume per second. So this is equal to rho into area into velocity, area into velocity, that is velocity meter per second, and area is also in meter square. So this is volume, this is rho a v. Force acting on the water is equal to rate of change of momentum. So this F equal to, this is the force acting on, force acting on the water is equal to rate of change of momentum, rate of change of momentum, momentum. So this is F equal to, F equal to mass per second, mass per second into change of velocity, change of velocity. So this is mass per second into mass per second into final velocity minus initial velocity. Here we have to find out this change of velocity with respect to this tank. So we have to find the final velocity minus initial velocity. In the earlier cases, we have used initial velocity minus final velocity because at that time we have to find out the force in the plate where the jet strikes, but here we have to find the force on the tank, so we have to use final velocity minus initial velocity. The initial velocity of water in the tank is 0 at the starting. When we open the orifice, the initial velocity of the tank is 0. Tank initial is 0. Tank initial is 0. So here the initial velocity is 0 and the water when it comes out from the jet is equal to final velocity is v. So this is the final velocity and it is v. So here f equal to rho a v into v final minus 0. So here this force, value of the force is rho av square, where we have to find out the force on the tank, rho a v square. Thus F is the force exerted on jet of water. This water will exert the force on the tank which is equal to F. So this is the force, this on the tank also, this is equal to F but in opposite direction. The direction is opposite to the force of the jet. The force will be acting at point A. Here if we extend this line of action, so this point is point A, the point on the tank on the horizontal line of the center of orifice. If the tank is free to move or the tank is fitted with frictionless wheel, here the wheels are frictionless, they can move in any direction. It will start moving with some velocity u. The velocity of tank start with the u meter per second in the direction opposite to the direction of jet. When the tank start moving, the velocity of jet with which it come out the orifice will not be equal to v, but it will be equal to relative velocity of jet with respect to the tank. So here v is the absolute velocity of the jet. So here v is the absolute velocity of the jet and u is velocity of the tank. U is velocity of the of the tank. V is absolute velocity of the jet and u is velocity of tank, and vr is the velocity of jet with respect to tank, velocity of jet with respect to tank. This is taken as Vr. Now then the Vr is the vectorial difference of absolute velocity v and the velocity of the tank u. So this Vr equal to v minus u. The direction of u is in the negative, so this has been taken as v minus u, that is equal to v plus u. So this is relative velocity is v plus u. Hence when the tank is moving, the velocity with which jet comes out from the orifice is v plus u. Now the mass of water coming out from orifice per second, mass of water, mass of water coming out, mass of water coming out, mass of water coming out from orifice per second, from orifice per second is equal to rho A into velocity with which the water water comes out, comes out. So this is rho A into V plus U, that is VR, that we can be written VR also. Now force exerted on the tank is given as, force exerted on the tank is given as is given as Fx equal to mass of coming out from the orifice per second into change of velocity, change of velocity, mass of water coming out per second from the orifice and the change of velocity. So here this is rho A V plus U and the change of velocity is V plus U, that is VR minus U. So this U and U are cancelling. So here we will get rho A V plus U into V. So that is rho AV, rho AV V plus U. This is the force exerted on the tank is given by this equation. Thus the force given by previous equation of propelling the tank, now the work done on the moving tank by jet per second, work done is equal to by the moving tank per second is equal to Fx into U. Putting the values, the value of Fx is rho A V into V plus U and this is multiplied by U. So this is the equation for the work done, and now for the efficiency, for the efficiency efficiency of propulsion is given by this eta equal to work done per second, work done per second is divided by kinetic energy of the issuing jet per second. Kinetic energy of issuing jet per second, the kinetic energy of this jet. So putting the values here, rho A V plus U into V into U by half of mass of water issuing per second, mass of water issuing per second into velocity of issuing jet, into velocity of issuing jet. Putting the values here, this is rho A V plus U into V into U, that divided by half of rho A V plus U. Here this is the mass of water striking, and this is VR, that is V plus U square. This one is V. Okay, V plus U square. V plus U square. Now cancelling this rho AV plus U, rho AV plus U, the coming value is 2VU divided by V plus U square. This is the equation for efficiency. Eta equal to 2VU by V plus U whole square. Next, condition for maximum efficiency. Condition for maximum efficiency and expression for maximum eta. Here, if we differentiate eta with respect to u and equating this to 0, then the maximum efficiency will be find out by d by du of this 2vu by v plus u square, equating these to 0. Now this d by du 2vu into v plus u to the power minus 2 is equal to 0, or 2vu into minus 2v plus u की power minus 3 plus v plus u to the power minus 2 into 2v equal to 0, or this can be minus 4vu by v plus u की power 3 plus 2v by v plus u power 2 equal to 0. Now, so this minus 4vu plus 2v into v plus u is equal to 0. Dividing both sides by dividing this equation by 2, we will get minus 2u plus v plus u equal to 0, and minus u plus v equal to 0. So u equal to v. But when this u is equal to v, putting this in the previous equation, substituting the values, so here eta max by putting this value, that is 2 into u is divided by u plus u square. So this comes 2u square by 4u square, that is equal to half. So this maximum value is 0.5, that is 50% is the efficiency of this. You have to practice some numericals on this topic.